video, I'm going to cover the powers of I. We talked about I as being an imaginary number, and the reason that I is an imaginary number is because I is equal to the square root of -1. So this doesn't exist, but in the form of I, it does exist. So the first thing that you always have to remember is when you see I, that stands for the square root of -1. If I see I squared, it means -1. If I see I to the third, it means -I. And if I see I to the fourth, it's +1. So this is called the cycle of I. And we can find out if there is ever an exponent that is greater than 4. You can always find out what that is equal to very easily by dividing the exponent of I by 4. If it divides evenly, meaning no remainder, then the answer is 1. That means 4 goes in there equally. And this would be like I to the 4th, I to the 8th, I to the 12th, so on and so forth. The next thing that we need, so the answer is 1. If you divide it by 4 and you have a remainder, if you have a remainder of 1, then your answer is I. The next thing, if you have a remainder of 2, the answer is -1. So it kind of correlates with if the remainder is 2, it's -1. The remainder is 1, it's I. And then if you have a remainder of 3, the answer is -I. Now I'm going to do some examples with this. I'm going to start fairly easy and then move forward from there. So let's look at the example of I to the 9th. I'm going to take my exponent, so 9, and divide it by 4. Pardon me, I don't know why I put 8 there. And 4 goes into 9 twice. And 2 times 4 is 8, and I subtract, so I have a remainder of 1. So I look at my rules and I can actually see that if you have a remainder of 1, the answer is going to be just I. Now, getting a little larger, I to the 51. I take my exponent and I divide it by 4, and I keep going, and that's going to go twice, -8, and I have a remainder of 3 here. And if I look over here, if you have a remainder of 3, the answer is -I. So these are things that you just have to remember. Now, taking it one step further, I can go and I can say, okay, I want to find the square root of -16. And I know that the square root of -16 can be broken up into -1 times 16. And looking at it this way, you know that this is the square root of -1 times the square root of 16. And the square root of -1 is I, and the square root of 16 is 4. So my final answer is 4I. Now, looking at something like the square root of -48. Okay? In this case, it breaks down again to -1 times 48. And I know that the square root of -1 is I. So I know that part. But I don't know, I know that 48 is not a perfect square. So I have to divide by 2 because it's even, and that's a good place to start. And so I keep dividing by 2, and so I'm left with all 5 of those numbers as the prime factorization. So I start pulling out pairs. I have a pair of 2's. I have a pair of 2's. Okay? So 2 times 2 is 4, and what I'm left with underneath is 3. So your final answer is 4i times the square root of 3. Hopefully that helps you understand some of the operations. Now, in my next video, I'm going to get into simplifying with complex numbers. So this gives you an example of just how to use the powers of I.